Please take a seat. Let's get started. So I added a couple of slides to this lecture. So if you downloaded the previous slide, you should do it again now. So last time I stopped while introducing how to make a connection to database using JDBC. So in this chapter, we will learn JDBC and PL, PGSQL, and this is what I added to the lecture slide. So why do we need JDBC or ODBC? So usually people use web browser to use database application, and web-based applications usually use HTTP protocol or REST API to connect a remote process. So usually applications are running in a remote machine like a cloud service. And suppose this application is using DBMS, then this application has to make a connection to DBMS using JDBC connection. Then this DBMS is going to store data in storage systems using file systems supported by operating systems. And in large-scale web services, usually it is common to run DBMS in a separate machine. So suppose your application is running on this upper machine, and this application can make a connection to DBMS running in another remote machine. In that case, still you can make a connection to this DBMS using JDBC or ODBC. And the reason why we use application is because DBMS is not a full-featured. It is not full-featured, so to support many functionalities like web-based UI, printer, and many other things better be written in high-level programming language like Python or Java. So using those high-level programming language, you can use while loop, if-else, conditional branch, and so on. So suppose you haven't written, although you haven't learned it yet, suppose you know how to execute those SQL statements inside your application code. So inside this application, we have 3 query statements. Then for each query, the query parameters will be transmitted to this remote DBMS, and DBMS is going to return the output table to this application. And for the next query, let's say you executed the query number 1, and the next query number 3 should be transmitted to DBMS. Then DBMS will return the output table to application repeatedly. But it might not be. Writing these multiple queries in this simple while loop or if-else conditional branch may consume too much network bandwidth. So sometimes we may want to. Sometimes you might want to run these conditional branch or for or while loop inside the DBMS. In that case, you can use PL, PGSQL that you are going to learn in the second half of this lecture. So let's first talk about JDBC. So last time we looked at this source code. So you make a connection, and using that connection object, you can create a statement and execute it. Then the output table will be returned to application, and the output table is referenced by a variable of result set type. And using this result set type variable, you can read each record of the output table and parse and retrieve individual column values from the reference. So if the attribute is of a string type, you can call getString method, and if the attribute is of integer type, you can call getInteger method. If it is a float type, then you can call getFloat method. And sometimes the output table may have null value in a particular attribute. Then you can call wasNull method to check the last attribute value that you retrieved is null or not. If it is null, then we print out this string capital null. Otherwise, we print out the integer value in this if-else conditional branch. All right, that was a brief introduction to JDBC. And suppose you have written this select statement inside a Java program. So this is a select statement, but somehow you made a mistake. So here, instead of calling, what is it? I forgot. Not execute query. Is it execute query for read only? Give me 1 second. Yeah, execute query is for select. Execute update is for write query. Oh yeah. Sorry, I was confused. I thought that this is query. So execute update method is for write queries like insert, update, or delete. But you can pass a select statement in update method. This is okay. But if you do that, then we have a problem. This statement is going to put your DBMS your database in danger. Why? Anybody? This is a very well-known problem in database application. SQL injection. Yep. Good. So this name is a variable of a string type, and suppose you have a web browser with a text box, and inside the text box, people will write some, any string. That string will be stored in this variable named name, and the user typed string will be simply appended to this where clause. And a malicious user, hacker, may want to mess up your database, and he may write something like this: Robert, and single quote, semicolon, and drop table, and table name. Then this string will be appended to the select statement, and that statement is going to be changed to the following statement. We have simple select statement where we find the student with the name Robert, but then we have a semicolon here. This will be executed as a single statement, single query statement, and then we have another statement saying that we want to drop the student table. So when user types this string in their web browser, and if DBMS executes these two statements, then the whole DBMS, whole student table will be deleted from your database. This problem is called a SQL injection. And there is a way of avoiding this problem. Instead of using a regular statement type variable, it is recommended to use another class called prepared statement. In this prepared statement, you are allowed to use these question marks. And then, using this variable of prepared statement type, you can call set method, like setString, setInteger, and each setString or setInteger, these methods will replace each question mark with a given string. And then, if user types single quote, actually the main problem in the previous example is that users have a freedom to use a single quote single quote in their text box. In their variable, they can put a single quote anywhere inside the string. But if you allow it, then single quote will close the user-defined string, and then the rest of the characters will be interpreted as SQL statement, SQL command, like drop table. So the solution to this problem is to escape character. Whenever user types single quote inside their string, every single quote will be escaped by this backslash. So even if user types this, this prepared statement class is going to put this escape character. So this whole string will be compared against the name attribute value. So this drop table statement is not going to be treated as a SQL statement, but it will be treated as a user string. Okay. Question? No question? Okay, good. Next. So it is recommended to use prepared statement instead of regular statement. And next, JDBC provides a class named result set metadata. Result set is a class type where we can store a table, output table, and result set metadata is a class where we store metadata about the result set. So to get this result set metadata, you need to obtain result set type variable rset from the execute update statement or execute query statement. And then you call get metadata method using that rset variable. Then this metadata reference will be returned. And from this reference, you can call get column count, which will return the total number of attributes of the output table. And get column name will return the name of each attribute. And get column type name will return the time name of each attribute. So when you execute this statement, when you execute this code inside the Java program, the schema of that output table from a given selected query will be printed out. Next, similar to the result set metadata, we have another metadata class called the database metadata. And this database metadata is used to get the metadata about the whole database schema. Using database metadata, you can get give me 1 second. Let's try this code. Do I have a sample code? It's been a while since I tried the code. So. Okay, here we have result set metadata example. Let's copy this code. And Java program, file name of the Java program must match the class name. So I changed it to JDBC example number 3. And here, instead of getting result set metadata, let's get database metadata. Let me just copy. the whole code. Oops. Huh? Oh, strange. Alright, let's try this. Inside this sample DB directory, we have a couple of JDBC example codes, and if you want to make your own example, create a new file and then compile. Put compile command inside this make file. And when you compile, you don't need any. You don't need to specify any option. Just give the file name. But when you run it, you should put some options. So this -cp option is used to specify the file path of JDBC library, and the library file is stored in the current directory. So PostgreSQL 42.6.0, this jar file is the JDBC library file. And then after you compile it, JDBC example3.class file will be generated. Oops. And let's compile. Oh, I got syntax error. Line 27. Oh, I need another. My parentheses. Parentheses is already defined. That's right. I don't need it. Let's delete it. I don't even need the statement. One second. No suitable method found for print line. String. I think this should be changed to plus. Okay, got it. Now let's run. Oops. Make JDBC run 3. Was it run JDBC? Alright. Oh, it didn't print anything? Oh, it is because this. So my database, this second argument of this get columns should be the database name, and I don't have. So my database name is bnam, so I changed it, and the next argument is the table name, and department. In my database I have student table, department table, and so on, and this get columns method is going to return the schema. of the department table. So let's run it one more time after fixing this issue. Give me a second. I will fix this example, and maybe you should try it by yourself later. I'm sorry. I should have done it before coming to this class. Anyway, so just similar to this result set metadata, you can get the schema table definition from this database metadata reference. And give me a second. Let me try one more time. Sorry. Let's connect to Enum and show department. I have department. Strange. Department. I don't know, something messed up. Sorry. And anyway, so that's how you can query database schema. And last time we briefly talked about the transaction concept. And by default, whenever you execute a query using execute update or execute query or execute update method, each statement, each SQL statement is going to be executed atomically, and you cannot roll back it. Once it is executed, it is done. But sometimes you may want to run multiple SQL statements and then treat them as an atomic operation. In that case, using the database connection object, you need to call set auto commit method with false as a parameter. Then transaction will begin. So transaction will begin from this line in your JDBC code, and then you can call multiple execute update or execute query methods. No matter how many methods, no matter how many execute update methods you call after this set auto commit method, they will not be reflected to the DBMS. They will be temporarily executed and kept. The results will be kept in the main memory of the DBMS, and only after you call this commit method, those updates will be reflected to the database file. Okay, and suppose out of 10 execute updated statements, you executed only 5 of them. And then you found that something went wrong, something is not right, then you may want to cancel the whole, you may want to cancel those 5 statements. Then you should call this rollback method. Then those 5 queries will be cancelled, and the database state will be rolled back to the previous consistent state. After you finish your transaction, if you want to execute each statement as a single transaction, then you should call this set auto commit method with a true parameter. Then every single individual query will be executed as a transaction. And later today, we will learn how to implement some procedures inside DBMS using PL/PG SQL. So once you implement a function or procedure inside PL/PG SQL, you can call those functions in your Java program. To call a function, you should use this prepare call method using, again, JDBC connection object. After you prepare this statement, this prepare call method is going to return a reference of callable statement type. And similar to other prepared statement or just regular statement type object, you can call execute update or execute query method using this variable. Then the corresponding function or procedure will be executed inside the DBMS, just like regular select or insert query. And we learned that DBMS supports blob or club type, large object type. And in Java or other high-level programming languages, there is no blob or club type. Instead, we have a stream type. So when you have a large multimedia file, you can open the file using input stream, right? If you want to store large multimedia data to disk storage, you use output stream. So this set blob method associates a blob type object with your multimedia input stream. And to associate your multimedia input stream with a particular attribute of a attribute of a record, you need to create prepared statement type object. And let's go back here. Let's assume that you are inserting some data into this instructor table, and let's assume that this last column is of blob type. Then you need to open your file using input stream, and what's the index? 1, 2, 3, 4. This index of this last parameter is 4. So you should call this method p statement set blob number 4, comma your multimedia input stream. Then that multimedia file will be stored in the instructor record. That's how you use blob type object inside the JDBC. And ODBC is language independent. So JDBC can be used only in Java program. In Python or C, C++, you cannot use JDBC, but instead you have to use another connection library called ODBC. And the basic usage is similar, although just function names are different. So we are not going to cover ODBC in our lecture. And Python is not a popular programming language for database application. So C, C++, they suffer from pointer issues, memory management issues. So they are not also popular. Only Java and Java variant like Kotlin and other Java variant are commonly used to develop database applications. So you can ignore these slides, but I just listed these slides just in case you are interested. Using some different functions, we make a connection and then call. You create a SQL statement type C-string variable. And pass that SQL statement to this function, SQL execute direct function. Then it's going to return some record as an output table type. Then using bind variable, you can bind a specific variable of C language with an attribute of that output table using this SQL bind column function. And SQL fetch will fetch every single record whenever it is called. So whole structure of this program is not very different from JDBC program. So only if you are interested, look at these slides. And of course, they are not, ODBC is not going to be covered in the midterm exam. And also, it is not going to be a part of your assignment. So let's skip these ODBC related slides and let's move on to PGSQL. So Postgres is a copycat of Oracle DBMS, and Oracle, the company, developed an extension of SQL. The main reason is to support those programming languages constructs inside the DBMS. So suppose you put these while and if else these logical structure inside Java application, then for each query, application and database management system should make a should transmit some data repeatedly, and that is going to waste network bandwidth. So instead of implementing these simple code structure inside your high-level application, high-level language application, you may want to execute this logic inside the DBMS. In that case, you can use PL/PG/SQL in Postgres. If you are using Oracle, you can use PL/SQL. PL/SQL, their syntaxes are very similar. There are not many differences. So once you learn PL/PG/SQL, you can also implement PL/SQL program. So SQL is a declarative programming language, so it doesn't support if then else, for loop, while loop, etc. But people found that this is too restrictive. Skilled programmers want to use these if else, for loop inside the DBMS. So they implemented, Oracle implemented this extension called PL/SQL. This is how you can implement a procedure or function inside the DBMS, inside the Postgres. Anything inside this square bracket is optional construct. You can ignore this. So it starts with this keyword create, and if your code returns something, the next keyword should be function. If your program doesn't return anything, this should be changed to procedure. And then usually defined the function name follows, and the function argument should follow. And returns keyword specify what is returned from this function. You can return a Scala value. You can return a table. I have some examples in later slides. So we will see those examples later. And then we have as keyword. As is for rename operation. So, what this means is, if a function name is used inside your SQL statement, then the function name should be replaced with this function body. That's the meaning of this as. And then we have this double dollar symbol. What is this double dollar symbol? This is escape character. This is going to be used to terminate a SQL statement. Without this, semicolon is interpreted as the terminator. Right? So inside the Postgres, here inside the Postgres, anything you type before semicolon will be interpreted as a SQL statement. Okay? So suppose you are creating a function f returns int as, and let's say you put semicolon here. I haven't finished writing the function body yet, but my function is going to contain multiple SQL statements, so there must be some semicolons inside the function body. But whenever you put semicolon inside the function body, this is going to be interpreted as the end of a particular statement. So you cannot finish implementing your function body. How can you avoid this problem? After as keyword, you must put double dollar symbol. Then from now on, double dollar symbol will be interpreted as the terminator. Semicolon will be ignored. semicolon will be just interpreted as just part of the function body. Okay. So although I put this semicolon here, the SQL statement, I mean this Postgres doesn't complain anything because I haven't finished implementing this function body. Okay. Oops. That's the meaning of this double dollar symbol. So the function body has two parts. Declare is for variable declaration. Since this is a function or procedure, we can use some variables. Those variables must be declared inside this declare section. And then function body starts with this begin keyword. And since this is a function, we need to return something, and we use this keyword return, just like other high-level programming language. And the function body ends with end. Then we put semicolon, and then we put double dollar symbol. This double dollar symbol indicates that this is the end of the function body. Afterward, semicolon will be used as the terminator. Question?
So can we change this double symbol to another?
Yeah, you can use double pound symbol. You can use whatever you want. Good question. Any other question? No? Terminator, yeah. You know, in Python, I mean in C++, we have we use a semicolon as the terminator. Just like that, we use semicolon as the terminator in SQL. When you implement a function body, your function body will contain multiple semicolons. So we need to escape it. That's why we have this double dollar symbol. So let's look at a real example. The reason why we have or replace is because when you put this or replace, DBMS will check if a function with the same name exists inside the DBMS. If a developer has implemented total students previously, that function body will be replaced. When you don't have or replace, DBMS will successfully create this total student function only if the function doesn't exist in current database. Okay. But while you are implementing a function body, you may make some mistakes, and you may want to re-implement the function. I mean, you may want to change the function definition repeatedly. In the case, it is convenient to have this or replace so that the previous function definition can be changed. And this total student doesn't take any argument, and it returns an integer type. And inside the declare section, we have just one variable. Oh, here, interestingly, the data type comes after the variable name. That's quite standard in SQL. You know, in SQL, we put domain or type after the attribute name. Similarly, we put type after the variable name. And inside this function body, we have one single statement, select statement. This statement reads student table, and it counts how many records are stored in the student table, and store that number. This count returns the Scala value. That number will be stored into the following variable. Total, this is a variable declared in the declare section, right? And then we return the value of that variable in the next line. And we restore the semicolon as the terminator. And actually this is not necessary in Oracle's PL SQL, but for PL/PG SQL, this is how we end the definition of a function. This should come always. Mandatory. Okay. Suppose you have implemented this function total student, then afterward you can use that function anywhere. You can use that function anywhere inside the DBMS or inside your Java application. You can be used anywhere. Just like it is a predefined built-in function, like count function or average function. Okay.
I have a question about the as. You told us that the as is the rename operator.
Mhm.
So I want to know that if that as is the same as the select operator is as.
It's not exactly the same, but its behavior is similar. So, you know, when we use as operator in select statement or from construct, we are renaming this thing into this thing, right? We are renaming this to this. Similarly, we have as operator right here. So what we are doing is we are replacing this function name with this function body.
So in that case, it's kind of similar as the rename operator that we learned in select, but
Yeah.
it's not exactly the same.
It's not exactly the same, but their behaviors are similar. So here in the following statement, we use this total student function. This function should be this is a renamed. This is a string renamed for this function definition. Okay. Let's look at a little more complicated example. The name of the function is instructors of, and it takes one argument parameter of character type, character 20 type. So it can have maximum 20 characters. And previously, in the previous example, we returned an integer from the total student function. But here in this example, we are returning a table, not a scalar value. So we need to specify what attributes are, what attributes this table has. So it has 1, 2, 3, 4 attributes. And the attribute names are ID, name, department name, and salary, and their types follow those attribute names. Okay. And then the function body starts from here and ends here. What it does is it should return a table, and table can be obtained only from a query. So we need to return a table. That is why we have this keyword query. It says that we are returning a table, not a scalar value. And then we have a simple select statement. What it does is it is just selecting instructors from this department. What is this? Oh, here we don't have a declare section. And this instructors of that D name, where do we have this? Right here. Instructors of is the function name, and D name is the parameter name. And we use this path expression using dot operator. So function name dot parameter name will be replaced by the actual value passed to this function. So look at this usage example. We are selecting everything from table. Oh, what is this? This is the first time that we saw this here. This table means we are calling a stored function in the database. And the function name is instructors of, and finance is the argument that we are passing. So this finance will be passed to this function, and dname this variable will be replaced by finance. Okay, and then this select statement is going to return those instructors from finance department with 4 attributes. Bunch of records will be returned, and that output will be treated as a table. Okay. Following. Next, inside the PLPG SQL, we can use conditional branch, while loop, those classic, those conventional programming language constructor can be used. So if else is used to check certain condition, and if the condition is true, we execute if block, otherwise we execute else block, or if the second condition is true, we execute this middle block, and so on. This is how we can use if-else statement. If, then, else if, then, else, and end if. And strangely, I found this is really weird. We have white space in between and if, but we don't have white space in else if. Sometimes this is confusing. This is very common mistakes while developers are writing in PLPG SQL. I don't know why they did it, but that's how they implemented it. Next, so let's look at an example of if-else conditional branch. Oh, what is do? What is do? Instead of defining a function, you can just execute these statements just like a shell script. This is an anonymous function. It doesn't have a name, so this anonymous function or procedure cannot be called in any other place. These if-else conditional branch and these statements will be just executed only once. So it works like a script. Still, we need to change the terminator. And inside the declare section, we have one variable. For assignment, we are using colon equal symbol, not equal symbol. This is an assignment. And we check if that variable is less than or equal to 18. If so, we call this raise notice. What is raise notice? This raise notice is like a print method. So this following the next string will be printed out in your console. Any question about this example? No?
So, does it, can it have a return statement or not?
This procedure, this code cannot be executed anywhere else, so there's no meaning. There's no reason to return anything from this. So this is, maybe I should change this. This is not a function, but it is rather a procedure, which doesn't return anything.
So is it kind of method or something else?
I wouldn't say macro. Macro is to be used by other places, but this is not. This cannot be used in any other place. It seems this doesn't match with the example of the slide. I guess this state. I just copied this line from another slide. Please ignore it. And question? No? Oh. No. Do and as, they have different purposes. So as is used to define a function, and do is to implement anonymous procedure. And we have a case statement, and this case statement may have expression at the top line, or it may have Boolean condition in each when construct. When you have an expression right after case, then when constructor should have a value for the given expression. If this expression has this value, we will execute this statement. Next, this is an example that uses the case statement. This is the first time that we see for loop inside DBMS. For now, let's ignore it. But it looks similar to other, it looks similar to for loop of other programming languages. We just iterate and execute these statements. That's the meaning of this for loop. For now, let's ignore it. And again, we have anonymous procedure. And here we have two variables. And we check whether this variable's value. We are not checking this. We are checking the value of a letter, and if the letter matches A, we assign number 4 to a variable named grade value. If this letter is B, we assign number 3. If it is C, we assign number 2, and so on. After that, we call raise notice statement to print out the following values. What is percentage symbol? When you have two percentage symbols, two variables should follow. So the value of this letter will be shown in the position where we have a percentage symbol, and grade value will be shown right at this position. Okay, that is how we use case statement. And now let's talk about loop. If you don't have any expression after loop, it's going to be infinite loop. So to get out of this infinite loop, you should call exit statement. And we have a while loop. While loop requires Boolean condition. So only when this Boolean condition is true, we iterate the following block. So let's look here. Give me a second. We don't have a syntax for loop, but just examples. So for loop, we need iterator variable, and then in follows, and then after in we should have a set. Then for every element of this set, it is going to be assigned to this iterator variable, and that iterator variable is used in the following statement. And the for loop will end with this end loop construct. Oh, I forgot. I missed loop construct at the end. Loop, in, for, and loop. And this set can be selected statement, it can be, I mean, you can put select statement after this in construct, or you can use this range of an integer number after in construct. So this code is going to just print out I equal 1, I equal 2, I equal 3, and so on. And the next statement, oh, here we have that example. Here, after in construct, we call select statement, and this select statement returns two attributes. But here we have just one single iterator variable s. But that is okay. S is declared as, S is declared as a record type. Record can have arbitrary number of attributes. And to access each attribute of the record, we should use this path expression. Iterator variable dot attribute name. Okay. Next. Another option is to use an array. What is dollar number one here? It is the first argument of the function. So here, scan rows function takes an integer array type parameter, and when a user calls this scan rows function with an array, that array can be, array will be referenced by this special variable dollar number one. If the array is passed to this function as the second argument, then this dollar one should be changed to dollar number two. It doesn't have to be an array. To use the argument in this for loop, of course, it should be an array. Otherwise, there is no reason to iterate. But let's suppose we have another argument. The third argument is just of an integer type. Let's say x int. Then you can use the variable name x, or you can use dollar number 3 to reference this third argument. So dollar one indicates the first argument, dollar 2 indicates the second argument, and so on. Anyway, so here in this example, dollar one is referencing the argument array, and to iterate that array, we use for each construct, and this variable x must be of integer type because that array is of integer type. Okay, any questions so far?
What is the difference of 4 and 8?
So I intentionally removed that slide for this semester, but so when you use a for loop, this iterator variable x will iterate each single element. So let's say you have 10, then x will get number 1, number 2, number 3, and number 4. But when you use for each, you can take one single argument, or you can take two arguments at the same time, or you can have some stride. What I'm saying is, you can put some additional options in this for each statement to iterate the first one, and then jump to the third one, and jump to the fifth one. We call that a slice. So for each statement is used to iterate a given array or set using some sliding window. what I'm saying is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's suppose we have these 10 elements in a given set. You may take 2 arguments, and then in the next iteration you can get another 2 arguments, 2 elements, and then in the next iteration you may get 2 elements. So the size of the slide in that particular example will be 2. You can read 2 elements at once. So anyway, so this for each construct is much more powerful. It provides more functionality than just regular for construct. But I'm not going to cover those details of this for each construct, because I guess that is, if you need that feature, you should Google and reference it. Next, trigger. Trigger is a query statement that is executed automatically when a condition is satisfied. For example, suppose that you are implementing some auction website like eBay. So you want to sell your item, and you want that auction to continue until tomorrow evening, tomorrow midnight. And also simultaneously, at the same time, you may want to stop that auction if someone is willing to pay higher than a certain price. So when certain condition is satisfied, like when the time passes over a certain time limit, or when the price is higher than what you expected. Anyway, so if those conditions are satisfied, you want to execute this function automatically. Even if user didn't submit any query, this statement is going to be executed because that condition is satisfied by internal transaction mechanism or whatever. So we have some more examples listed here. So suppose you are implementing a banking application, and everyone has some balance, like someone has a large amount of money in their account, some people have a small amount of money, and let's say you have just $5 in your account. And if that customer withdraws $10, that should be prohibited. Well, you know what? In America, in the United States, this is allowed. Even if you have just $5 in your account, you can withdraw $10. But later you need to pay penalty. So we call that overdraft fee. And those conditions are monitored in the background, and if the condition is satisfied, if the condition is met, trigger function, trigger statement is going to be executed. So how can we implement that trigger? Syntax is given here. Usually defined trigger name comes after this create a trigger construct, and after the trigger name you need to specify when you want to execute this trigger, or on which event you want to trigger this procedure. And this event should be on a specific table. Trigger time can be either before or after. Trigger event can be either insert, delete, or update. So suppose you created a trigger X, and the trigger should be called after insert on, let's say, student table. So this second line is written like this: after insert on student. Then, whenever someone inserts a new record into student table, the following for loop will be executed. Okay. So an example is shown here. This is just regular function. This is a function with this name. It doesn't have any argument, but it returns a trigger type. Because this function is going to be used as a trigger. So you should say this function is supposed to return a trigger. And the trigger definition is given below. The trigger name is update budget. So whenever a new instructor is hired by a certain department, that instructor information, that instructor record will be stored in that instructor table. And whenever that a new instructor is inserted into the table, another table, department table, should be updated to reflect the new instructor's salary. So the budget of the department should be updated. What I'm saying is, let's suppose in computer science department we have two instructors, Alice and Bob, and their salaries are like 100 and 200. And if you look at the department table, we have a CS department and their budget is 300. Okay? This is instructor table. And their department computer science. And when a new instructor, let's say Charlie, is inserted into this instructor table, simultaneously, the budget of computer science department should be increased to 600. We can implement this logic using trigger, and that example is given in this slide. So what it says is, we need to monitor instructor table, and if a new record is inserted into this instructor table, then the following trigger should be executed after the insert. And what does it say? For each new record, we want to execute a procedure named update budget. What does this update budget function procedure do? Let's look at it. It doesn't take any argument, but still we can reference the new record using a special variable called new. This new is referencing the newly inserted record, and the newly inserted record may have multiple attributes, and those attributes can be accessed using the start operator. So we check if the new instructor's department name is null or not. If it is null, then there's nothing we can do. If the department name is non-null, then we update the department table. How do we update it? We check the department name attribute, and if the department name attribute is equal to the new instructor's department name, we update the corresponding department budget. We are adding the new instructor's salary to the previous budget of the department. Okay, and then we need to return. I mean, this is a given. This is how we should do it. How we should put at the end of the procedure for trigger. I don't think I can explain this right now. But anyway, this is how we do that. For trigger procedure, we must return new. And the type of the return type should be trigger type. Question? Any question?
So it's a case of when you insert a new row. So when the case of data to update, can we use some token instead of you?
If it is not insert a trigger, but what if it is update or delete event, then what should be the variable? That's the question. I don't know. That is a really good question. I honestly do not know. I should check it. Google it after class, and you will find it. Yeah, definitely it shouldn't be new for delete operation. There should be a variable that can reference the deleted record.
We make a function of the project, but we extract a procedure. Why?
That is just how they did it. So his question is, when you create a trigger, this says that we are executing procedure, but why we are implementing a function, not a procedure? I don't know. That's just how they implemented it. Don't blame me. It's not me. Yeah, I worked in Oracle, but I didn't implement this SQL parsing and those things. I worked on the backend side. I worked on this event monitoring system. Give me a second. I have just 2 more slides. You know what? Oracle is really old software, so not many people could access the source code of the core database engine. And once I had a chance to look at the source code, and it was cryptographic. I mean, so a long time ago, we had a machine with a really small memory, and when you compile your program, the program binary code has this symbol table, and the symbol table should be as small as possible. And if your variable names are long, then the size of the symbol table grows. So when this Oracle DBMS was first developed, they tried to use very short names for the variables and function names. So if you look at the function name, it is all acronym, like MVF blah blah blah. Oops, I don't know what those each character means. So I mean, I had a chance to look at the source code, but I couldn't parse anything. What is this variable? What does this do? I don't know. And, anyway, I didn't work on the core modules of DBMS. Anyway, let's move on. So, what is this? This is an example how trigger is executed. So we access this department table, and it says that the computer science department has $100,000 maybe as a budget, and then we insert a new instructor with salary 30,000. We didn't touch department table, but since this insert statement is going to trigger the procedure, the function that we implemented in the previous slide, when you run the same select query, you will see an updated budget. Okay, last slide of this lecture. So we just learned that you can use JDBC connection to connect high-level language program with DBMS, but some DBMSs are library, like SQLite. SQLite is an embedded database system. Then you don't need a JDBC connection. You can directly call those SQL features from your Android application. And also, I believe this is an out of scope of this class, so we are not going to cover it. But if you're interested, then you should look up your textbook. Okay, that's it for today.